So next topic in the chapter number 4 is titration. So this is a new terminology or new word, titration. What is the definition of titration? Titration is used to determine the concentration of one solution by using a solution of known concentration called a standard solution. So there will be two solutions in a beaker where A solution we know the molarity of A and how much volume of A we are taking, and in the B beaker we will do not know the molarity and we might know the volume. So if this is the situation, to find out the volume or the molarity of the other solution, and so titration is used to determine the concentration of one solution. For an example, solution B, using a solution of known concentration, example is solution A, called a standard solution. So this solution will also called as a standard solution. So this will be standard solution and this will be unknown solution, unknown, where we don't know the concentration. So there are two important terms. One is called equivalent points. Equivalence point is the point at which stoichiometrically equivalent quantities are mixed. Means molarity of 1 mole of one solution are equal to mole of other solution. That point is called equivalent point. And another terminology is, another word is used in the titration is indicator. Indicator means how we will know that we reach at equivalent point. How we will know that we reach at equivalence point. So indicator is used. So indicator die, they are colored die, which signals the end of the titration. They shows the titration is over and titration has reached its equivalence point. So indicator help to see us, to find us the equivalence point. Last part is the end point, the point at which the indicator changes the color. So usually the colored dyes, they change the color when the end point comes. Basically, for an example, when HCl is a hydrochloric acid, this is an acid solution. If I will dissolve this HCl in water, so this will become aqueous solution of HCl, which is acid. And if we know the M1V1 for this HCl, and we have suppose 100 ml NaOH, and we don't know how much molarity of this M2 will be, and this is the V2, which is 100 ml NaOH, which is the base sodium hydroxide. So here you have studied that HCl and sodium hydroxide, when they react, they form salt and water, and this reaction is called acid base reaction or neutralization reaction. So using titration, one can find concentration of sodium hydroxide by reacting hydrochloric acid and sodium hydroxide. Let's understand this reaction in the terms of titration. So for an example, we are taking HCl and NaOH. So if you have, now we are talking about that we have taken HCl here, 20 ml of acid. So let's talk about HCl plus NaOH is equal to sodium chloride plus water, and we have taken 20 ml of acid solution, but we do not know. Now we are writing this as a M1 and V1. We know that 20 ml V1 is there, but we do not know the M1 for HCl. So what we have to do, we took a burette, which is long graduated cylinder type of glass apparatus, and fill this with the sodium hydroxide solution, which is called a standard solution, and we know the concentration of this solution, that would be M2, and then we have to find out the V2 that has been used for the neutralization of 20 ml HCl. So we will take the 20 ml HCl at the in this B conical flask, and then add few drops of indicator, and then once this sodium hydroxide standard solution is filled, usually it is written as here 0 ml, and this will be probably 100 ml or 50 ml, that will be depend on the length or the volume of the burette. Suppose this is 100 ml. So you have to open the stopcock, and then slowly sodium hydroxide solution will be poured in the solution of HCl, and sodium hydroxide will start reacting with HCl. It will start making sodium chloride and water, and after certain point, when you will see the color has been changed for the indicator, and then you can stop the stopwatch, and then read the volume is written here. Suppose it is written 95 ml. So this 95 ml would be V2. So from this titration we would know that the 95 ml of M2 concentration of standard solution was used to neutralize 20 ml of HCl, and now we know we can M1 V1 is equal to M2 V2. We can plug these values into this formula. We do not know M1, but we know the V1 is 20 ml. We know the concentration, the M2, and we find the volume V2 from this titration 95 ml, and then using three values we can find M1. So this is a kind of analytical technique in which one can calculate the concentration of a solute in a solution. So this was the example how the titration process works, and let's see one more figure. This shows when you start the titration, you have to use usually drop by drop and keep mixing acid solution through this one, which you have in the conical flask, and then go very slow. If you not go very slow, color indicator will change very fast, and then you will not be able to find the equivalent point or end point. So once you will add one drop and you will see the color is started coming out, then you can keep shaking, color will gone. So look like still you have some acid and still it can be neutralized by sodium hydroxide. So you can add another drop and then again shake it. It will go but very slow, and then again you add it one more drop, and then you saw the color persist, it don't go. So this point is called equivalent point or kind of end point. So at this time we can note down how much volume of standard solution was consumed by acid to neutralize it. So this is the way the titration process works. And if we have to do some type of calculation to find out the concentration or the volume of a acid or base or one solution or the another solution, so you can follow this flow chart, that volume of a standard solution needed to reach the equivalent point means if we are talking about M1 V1 is equal to M2 V2 if this is HCl and if this is NaOH, which we know. So this is known solution and this is unknown solution, unknown, or you can also call this as a known or a standard solution. So in case of standard solution we have to find out V2. So use the molarity of a standard solution means M2 moles of the solute in the standard solution, then use coefficient from the balance equation. In case of HCl and NaOH the coefficient is 1. Then you have to find moles of the solute of unknown solution, number of moles of unknown solution for HCl, and then use the volume of known solution to find the concentration molarity of M2. So this is the pathway for titration calculation. We will understand better when we will solve some more questions. So a solution of a known concentration called a standard solution is used to determine the unknown concentration of another solution, and the concentration and the reaction is complete at the equivalent point, which is based on the seen at end point, which is you will see the color has been changed. So let's understand one calculation, then we can understand better. So how many milliliters of 0.200 molar acetic acid, this is acetic acid, solution is used to neutralize 50 ml of 0.0875 molar NaOH. So if we will try to solve this question, so basically what to do, we will take a NaOH solution. Here NaOH solution, okay, how many ml of acetic acid is required to neutralize 50 ml of 0.08 molar NaOH. So here we have taken NaOH solution in the beaker and acetic acid is filled in this burette. So we know the volume and we know the concentration of NaOH, so that we can write as M2 and V2, and then volume of HCl, volume of acid, and molarity of acid is given, so that we will give M1 V1. So we have to just plug all these value into this equation. M1 V1 is equal to M2 V2, so we have to find V1. So V1 will be equal to 0.2 molar of acid is equal to molarity of NaOH and multiplied by volume of NaOH. So then this value will go at the bottom at the denominator, and the molarity will be cancelled out, and once you will calculate these values will come 21.875 ml of volume, or we can also write like 21.88 ml of acetic acid will be required. So this was the one simple practice question for titration, and then we will see two more questions if we have a diprotic acid and some other acid and base.